Hello everyone, welcome to podcast. And today we'll see introduction and implementation of Deepseek R1. As we know, it is a quite popular model and it is going very competitive with the Chat GPT. And so we'll see how it works and how it is implemented in our local Google Colab. So starting with the introduction, it is an open source, as we know, general purpose LLM for both English and code. So we can use Deepseek R1 for textual output and for coding also. And it is trained with 1.4 trillion tokens, which is a quite big data. And it supports 7 billion and 57 billion versions. There are also middle versions in between, which we can use for our personalized tasks. Now it supports models like DeepSeek Coder, which is code focused, and we can perform tasks like reasoning, question and answering, summarization, and code generation, which is generally done by the other LLM models also. Moving on, the key features of Deepseek R1 are it is trained on both natural language and coding, and it is very competitive performance with GPT-4 class model. It is released under MIT license, and it is flexible for user modification, and it also supports instruction tune and base variant. So these are the key features of R1. Now, moving on to the implementation parts, we'll see in implementation also. On Google Colab how we could install Deepseek R1 and how we could get output from it. First technique is load using Hugging Face transformer. We can use the Hugging Face library for and using transformers. We can also using transformers accelerate and optionally bits and bytes can be also used while implementation of R1. Here are some of the implementation part. We need from transformers, we need auto tokenizer and auto model for causal LM, and we have to mention the model ID here. First of all, we need to tokenizer, auto tokenizer from pretend, and we need to mention the model ID for the model specifically, auto model for causal LM, and from pretend we need to mention the model ID and device mapping auto. While generating output with R1, we need to import the pipeline from transformers, and in that we need to mention the task. The task is text generation. We need to mention the model and the tokenizer. And while generating the response, we have asked the question, what is DeepSeek R1? The maximum tokens is 100 here. We need output around 100 and we will get the response. And it is ideal for question answering, summarization and text generation. Now the applications of R1 are content generation, blogs and summaries. As we know that it can generate textual output, so it is generally used for blogs and summaries, for code generation and debugging, reasoning and instruction following, education and tutoring, and research assistance and agents. These are the applications. The advantages of R1 are it is an open source, first of all, and it is transparent. We can adjust the weight also of the R1 model. We can customize it and also tune it. It is generally gives high performance on multiple benchmarks. So for complex tasks, we can use this model. It is cost effective to run versus commercial APIs. Now, challenges or considerations in R1 are it requires more compute to run locally. If you need to download the model, the computational power of our local system should be higher, and deployment complexity versus APIs like ChatGPT. While deploying the model, it is much complex task as compared to the ChatGPT, which can be accessed through APIs. Now we should manage security updates and infrastructure. Actually, after the some time, the model gets depreciated in some cases, so we need to take care of that part also. If any updated version is available, we need to upgrade with the current model. And infrastructure, like we know that it needs more GPU and more memory, so we should also manage that while considering the R1 model. Now, in summary, as we know, it is an open source model and it is one of the most powerful ones. So it supports both natural language and code-based tasks. We have seen this earlier, and it is flexible for enterprise or academic deployment, and it can be easily accessed via Hugging Face and Transform. Now we'll see the implementation part. Now, first of all, while you are using the Google Colab, you need to connect to the GPU of our Google Colab, and is required while installing the Deepseek R1. So first of all, the step one will be we need to install the required library. So we'll install that required library. Pip install transformers. Then we need accelerate. Then bits and bytes. Then we need sentence key. Now second step will be we need to import library. From transformer, we need to import auto model for puzzle LM, and we need auto tokenizer, and we also need torque. Now, third step, we'll start with loading the model with 4-bit quantization. We'll quantize the model because for current task, we don't need a higher model. First of all, we'll win the model name. Deepseek AI R1, distill 1. We will use the 7 billion parameter model. We'll mention the tokenizer, auto tokenizer from tree train, and we'll mention the model name here. And we'll define the model from tree train, model name. We need to mention another parameter also for the device map. We mention the auto torque detect, reduce the torque float 1. Load in 4-bit, mention it 2, and plug to remote port will make it that group. Now moving on, step 4 would be inference. We'll give a prompt playing Deepseek R1 in short. Then we'll mention the input, tokenizer, mention the prompt, content will be Python, and 2 put on output. You mention the model dot generate. You need to mention the input here, max new token for number of tokens we want in output. We'll mention it as 200, and then we'll print the output. And tokenize dot default put of 0 pixel token equal to 2. Then we'll exit the file. It will take some time, around 3 to 4 minutes, for downloading the tokenizer and the model. And we'll discuss the each line of code which library plays what role. And just keep in mind, we need to use GPR if you cannot work in the case of implementation of the R1 model. It is installing the required library currently. I've made some changes to the code. I've removed the loading. We are not quantizing the model in 4-bit, and the code is working now fine. Previously, we had used the load in 4-bit is equal to true, but it is showing error. It cannot quantize in 4-bit. So we removed that parameter, and now it is working fine. Till then, we'll see the use of each library. So first of all, with the transformers one, it is Hugging Face library basically for loading the pre-trained model. Next is the accelerator one. We use to optimize model distribution across GPU. So accelerate is very important. And we have not use the bits and bytes, but it enables the 4-bit or 8-bit quantization, and it reduces the GPU memory usage. Sentence piece is a tokenizer backend for many LLM. including DeepSeek. Then moving on, the auto model for causal LM, it loads auto-regressive model like it loads auto-regressive language model like Deepseek R1, and for auto tokenizer, it handles text token conversion. Now here we have mentioned the model name. It is official Hugging Face model ID. Now here we have mentioned the model name, also the device map as auto. So it automatically fetches the model on GPU or CPU, whatever it is comfortable with. And here you have mentioned the torque type. It has torque load 16. So it uses the system with precision, and it is used to reduce the memory allocation. Here we have mentioned the trust remote code equal to true, which allows custom model code execution. The device map auto, it accelerates the handle, which is the GPU CPU allocation. And here the torque G type basically balances the DRAM memory, and in case of the remote code, it is required for non-standard architecture. Here we have given a prompt, explain DeepSeek R1 in short. The tokenizer, it converts text to token IDs, and return tensors we have mentioned as PT, so it will return PyTorch tensors, and to CUDA is basically used to move tokens to GPU for faster processing. In case of the output here, the generator will run the model to produce the text, and we have given here maximum tokens as 200. So the limit output length will be around 200. Your decode will be used to convert token IDs back to human readable text, and its special tokens is omit basically like beginning of sentence or end of sentence text like this token. You have got the output, and we had mentioned the prompt about explaining the DeepSeek R1 in short. We had mentioned the definition, how it operates, its application. So yeah, in this way, we can use DeepSeek R1 in our local Google Colab system, and we can execute the model by giving the prompt and whatever the expected output we want from the model. We can do the text generation as well as the code generation. Hope you guys like the video, and please like and subscribe our channel, and click on the bell notification to get the latest video. Thank you.